All right, so as we were mentioning, we're working on 7.7. This is day 2. And as we mentioned in class yesterday, we were talking about the Ferris wheel and specifically about parametric functions, where we define two variables in terms of a third, most often time. So the time is the independent parameter, and then the x is the horizontal distance of the object, and y is the vertical distance of the object. And so we're going back to our Ferris wheel, which we defined at the beginning of chapter 6, unit 6. And so we have our first equation for the horizontal distance, so for x. And so cosine, if you recall, the shadow on the ground of the Ferris wheel moving back and forth this way. And 25, because that was the radius of the Ferris wheel. Pi over 10 had to do with the period. And if you recall, it's not the exact period, but pi over 10 divided into 2 pi gives me 2 pi times 10 over pi, which is 20, because it took 20 seconds for the Ferris wheel to make one complete rotation. And this little great black mark is confusing me, so let's get that out of the way. So 20 seconds for its completed rotation. And so that's where 10 pi came from. And then we're looking down here at sine of x, sine of the y, which is y of t, equals sine of pi tenths over t plus 30, and the 30 was the center of the Ferris wheel. So your Ferris wheel center right here, our starting position of A, and the vertical distance, the distance above the ground at any given point in time. Whereas this is the horizontal distance, left and right. So this is vertical distance, and this is horizontal distance. So this is our parametric function. Now what I want you to do is go ahead and get your own calculator. Let's not use Desmos, so if you can use a physical graphing calculator. You're going to change the mode on the calculator to parametric mode. So let's see if nope, I never did install it on this computer. So we're going to change the mode and then put them in. So once you've changed modes to parametric mode, as we talked about in class yesterday, your calculator will automatically default to allowing you to do t for your variable, and it'll give you two equations. So type this as your first x equation, and this is your y equation. Pause the video if you need time to do that. Then the next thing you want to do is set up your window. So I've set everything up in Desmos here. So you'll notice with Desmos, you do it as an ordered pair. And I've set it, so there's my x coordinate and there's my y coordinate. As an ordered pair, you're doing it x equation on one and y equation on the other. Now t, I've set up to be the period. So I've got 0 to 20, because that's how long it takes it to do a circle. So in your window, when you're after you've put the equations in, click on the window button on your calculator. In your window, you're going to want to set up your equation there. So my x-axis, I originally had it set to from negative 45 to positive 45 before I moved everything, and my y-axis from 0 to 60, because then you have what you can, we only know, and it makes it more square. See how the squares are square here instead of being elongated? I just figured that's a great idea. So you've got everything set up. Your calculator is going to do a beautiful thing because it's going to draw it as time passes. My calculator is just going to show it. Desmos just pops the image up. So hit graph and watch what happens. So I'll hit graph, and what did I get was a circle. So yours, let me just jump back over here. Yours should have started you here. That's not what I wanted to turn on. Started you right here and gone this way and slowly plotted the circle as it went around. And if you didn't go all the way around, it's because you didn't change t in your window. So make sure you change t from 0 to 20. Do not change the t-step. It makes it more jerky, and you want to keep it really smooth. So keep your t-step small, and the default seems to work out just great on that. So there I am with what the graph does, which is pretty dang cool. Now, why does the graph do this? So as we head back to our other stuff, what was going to happen? So we know that we're following a Ferris wheel going around and around in a circle, and so that makes sense that it would create a circle. And then to fill these out, if you click on second and then turn on the table, it'll give you your time in seconds. You can set that to automatically default, or on this one I would have it so you can put in numbers and it'll tell you the position. We know at 0 we're starting again on our Ferris wheel right here. At 0 we're 25 feet away from the center and 30 feet above the ground, and so that's the answer we should get. So what you want to do is use your calculator to fill this out, or you can plug everything into the equations. It's a little nicer to have the calculator do it for you. And so with your table setup, you'd want it to be set so that you can change the things. So you want to go into table setup and make sure that it's not on auto, it's on ask. So you can put in whatever numbers you want for your table. And then fill out the table. And just think about what's happening. Why is it creating a circle? Does it make sense? Why didn't we need to add 30 to the cosine curve? We've talked about all of these things before, but as we think about the parametric nature of the function, we want to think about them some more. So that's the lesson. Go ahead and pause I'm going to move on to your homework, but before you do, make sure you finish this table before you move on to your homework. Again, you're using your calculator to help you complete that, and don't spend too much time. Talk to each other about what's happening and what's going on, but then pause the video before I'm about to talk about the homework. So your homework has these strange looking graphs and is asking you to describe the motion and then try to draw it onto a regular coordinate plane. So in this picture we have x as a function of time, and in this picture we have y as a function of time. And so that's what we have going on here. And so at time 0, x is -5. So at time 0, x is -5, and y is +5. So we're starting here. That's time 0. And so just like yesterday when we were graphing that cursive B, we are going to be creating a dot to dot based on what we see in this picture. So x goes from -5 to +5 and is increasing. It's going to as it moves from -5 to +5, that means it's going right. And so at time 1, x is at 5 and y is still at 5. So this is time 1. But y held constant the whole time, so my vertical distance did not change, but my horizontal distance moved from left to right. So this is just from 0 to 1, and from 0 to 1 on y was a constant vertical distance. So that's what's happening there. And the idea is to follow and to create the dot to dot, but also to think about what's happening. So at time 2, x is at -5 and y is at -5. So this is time 2. And x went from right to left and y went from up to down. So it went that way, which is very important to understand. And then we have a constant again and a movement up. Same thing happening here. This is number 3. And then from time 3 to 4, we have x declining to, this is going to be position 4 is the same as position 2. And so we have 0, 1, 2, 3, and 4. It finishes back there if I did that. No, I did it wrong. Position 4 is incorrect. So position 4 is -5 and +5. So position 4 and position 0 are the same. So 0, 1, 2, 3, and 4. So we get this hourglass shape. So when you describe the motion, you want to say it went from left to right and then diagonally from right to left and down, then from left to right, then diagonally right to left and up. And so that's how we would describe the motion. So that's the idea with your homework. There's a couple of those. There's a couple with tables. It's pretty straightforward, other than these were very confusing for people in the past. I wanted to be sure we talked about it. I will see you tomorrow. Have a great day.